Has China truly cloned SpaceX's Starship? If you've noticed the striking resemblance, you're not alone. Join us as we uncover the intriguing saga of China's bold push into the space race and how it's taking cues from Elon Musk's pioneering designs. Today, we're diving into China's evolving space program and its uncanny similarity to SpaceX's Starship. China's ambitious plans to send astronauts to the moon involve a rocket design that has left many in awe, and perhaps Elon Musk himself wondering if imitation really is the sincerest form of flattery. Let's explore how China's Long March 9 is shaping up to look and operate eerily like SpaceX's Starship, and what this means for the future of space exploration. In the mid-2010s, China committed to putting astronauts on the moon and began designing a heavy-lift rocket for the mission. Initially, China's design closely resembled NASA's Space Launch System, SLS, a fully expendable three-stage rocket with solid boosters on each side. But as SpaceX pioneered reusability, first with its Falcon rockets and then with Starship, China shifted its focus. Chinese scientists began planning for a fully reusable heavy-lift rocket, incorporating SpaceX's innovations into their own Long March 9 design. This resemblance grew unmistakable over time. At a recent air show in Zhuhai, China showcased the latest Long March 9 model, which now mirrors Starship's look and functionality. The rocket will feature a reusable first stage powered by 30 methane-fueled engines, similar to Starship's Raptor engines. And like Starship, the Long March 9 includes an upper stage with flaps strategically positioned to aid in re-entry. When asked for his thoughts, Elon Musk seemed unfazed. Responding with his usual cool demeanor, he commented that aiming for reusability is indeed the smartest move. He's even encouraged competitors to adopt SpaceX's approach, highlighting how reusability is essential for achieving a multiplanetary future. But while Elon may be open to friendly competition, some observers see China's approach as something more systematic, a calculated strategy to leapfrog into space leadership. China's efforts extend beyond mere design similarities. Multiple private Chinese companies are launching Falcon-inspired rockets, adopting vertical landing technology, and even testing a chopstick tower catch method, an idea pioneered by SpaceX. Just recently, Cosmo Leap, a semi-private Chinese space company, announced its own reusable rocket program, incorporating nearly identical landing protocols. This fast follower strategy isn't limited to space technology alone. It's a common approach in high-stakes industries. China's space agencies and private firms meticulously study SpaceX's successes and setbacks, implementing proven technologies rather than starting from scratch. But it's not all smooth sailing. Numerous test failures, like the recent crash of Blue Aerospace's Nebula 1 and Space Pioneer's Chang'e 3, illustrate the difficulty in replicating SpaceX's reusability model. These incidents underscore the challenges China faces in achieving the reliability that SpaceX has painstakingly developed. China's determination reflects a broader geopolitical shift. Unlike the original space race, which focused on being the first to reach the moon, this modern rivalry centers on establishing a lasting presence there. Both China and the US recognize that reusable rockets will be vital for sustaining human activities on the lunar surface. China's dual rocket strategy, developing both the Long March 10 for short-term goals and the reusable Long March 9 for longer missions, highlights their strategic approach to meet immediate objectives while also planning for the future. Meanwhile, the US faces its own challenges in maintaining space dominance. SpaceX's ambitious Starship program is on a fast track, but NASA's continued reliance on the costly SLS system may affect America's lead. As both nations set their sights on the lunar South Pole, a region rich in potential resources like water ice, the question remains, who will secure a sustainable foothold? Beyond rockets, China is ramping up global cooperation in space, partnering with Russia on a lunar-based project, and securing collaborations with countries from France to Japan. These partnerships add an interesting dimension to China's ambitions, as they contrast with the US-led Artemis Accords, which have been signed by dozens of countries. The ILRS, or International Lunar Research Station, a joint Chinese-Russian initiative, represents a serious bid to rival the US in shaping international space policy. With an aggressive push for technological advancement and international partnerships, China's space aspirations are clear. Their soaring investments have fostered breakthroughs not only in rockets, but also in robotics, propulsion systems, and lunar exploration. As China continues closing the gap with the US, the impact of their space program may be felt not just in the skies, but also in the broader political landscape. While China has made impressive strides in mirroring SpaceX's groundbreaking achievements, there's still a long road ahead. But in the race to establish a lasting presence in space, imitation might just become the springboard for true innovation. Will China's strategy lead to new breakthroughs, or will it leave them forever in SpaceX's shadow? Only time will tell. Thanks for tuning in to Beyond the Cosmos. Don't forget to like, subscribe, and hit the bell to stay updated on the latest in space exploration and tech innovation. See you next time. Can China really catch up with SpaceX, or are they just chasing a dream destined to burn out? With explosions, ambitious launches, and billions in funding at stake, China's space race is heating up. But can they outpace Elon Musk's empire? Let's find out. In today's video, we're diving into the latest test flight from China's Deep Blue Aerospace. With comparisons to SpaceX's early Starship trials, this launch is more than just another rocket test. It signals China's growing ambition to rival the biggest name in private space exploration. Are we witnessing the beginning of a new space race between China and the United States? And if so, how close is China to overtaking SpaceX? Stay with us as we explore the successes, failures, and future of Chinese rocket technology. On September 22nd, Deep Blue Aerospace conducted a vertical takeoff and landing (VTVL) test with the Nebula 1 rocket's first stage at its E-Banner spaceport in Inner Mongolia. The rocket climbed to about 5 kilometers, deploying its landing legs on schedule and descending smoothly, until an anomaly caused a final engine shutdown failure, resulting in a fiery explosion. Despite the dramatic end, the company proudly highlighted that 10 out of 11 key tests were successful, including precision landing control within 5 meters of the target. This event marks China's first high-altitude VTVL test with an orbital-class rocket stage, an achievement strikingly similar to SpaceX's early Falcon 9 reusability experiments. Much like SpaceX's successful failures, Deep Blue Aerospace frames the explosion as progress, suggesting that even crashes provide critical data for future improvements. With another test scheduled next month, it's clear they're moving quickly to perfect their technology. However, the Nebula 1, measuring 11 feet wide, is smaller than SpaceX's Falcon 9, which stands 12 feet across. Currently, the Nebula 1 can carry 4,000 pounds to low Earth orbit, but future versions are expected to handle more. Meanwhile, Deep Blue's larger rocket, Nebula 2, aims to transport 20,000 kilograms to orbit, bringing China closer to competing with the likes of SpaceX's Falcon Heavy. China's commercial space sector is booming. Alongside Deep Blue Aerospace, other firms like Landspace and Galactic Energy are conducting similar reusable rocket experiments. With government support, state-backed enterprises like CASC and CASIC are also developing reusable launch systems. Beijing recently opened a new reusable rocket technology center to accelerate innovation. This aggressive push demonstrates that China isn't just chasing spaceflight success, it's aiming to dominate it. Still, China faces unique challenges. While they've mastered manufacturing in other industries, building reusable rockets on a large scale is a different story. SpaceX's success wasn't just about technology, it was about overcoming financial limitations. Elon Musk's lean startup mentality, fail fast, learn faster, enabled SpaceX to adapt quickly, refining their designs through repeated failures. Another key factor in SpaceX's rise was its close relationship with NASA. By leveraging NASA's expertise in securing key contracts, SpaceX transformed from a struggling startup to a spaceflight leader. COO Gwynne Shotwell's diplomatic finesse has been instrumental in building these relationships. In contrast, Chinese firms are still working to establish global partnerships and build a reputation in the competitive commercial launch market. Despite China's rapid progress, SpaceX maintains significant advantages. With over 98 launches in 2023 alone, compared to 67 by China, and more than 6,000 Starlink satellites in orbit, SpaceX's momentum shows no signs of slowing. Their ability to keep launch costs at around $3,000 per kilogram, much lower than the industry average, further cements their dominance. While China's advancements in space exploration have drawn global attention, the nation's ambitious program faces mounting criticism over safety risks. A recurring issue that has sparked significant concern is the uncontrolled re-entry of rocket components into populated areas, which exposes civilians to serious danger. This problem is primarily linked to the design and execution of launches using the Long March rockets, China's most widely used launch vehicles. Unlike companies such as SpaceX, which conduct launches over water or in remote locations to mitigate risk, China often launches from inland facilities. As a result, rocket debris frequently falls near villages and towns, causing property damage, endangering lives, and raising international alarm. One infamous example involved the Long March 5B rocket, which launched in May 2021. After delivering its payload, the rocket's 22-ton core stage re-entered Earth's atmosphere uncontrolled, eventually crashing into the Indian Ocean near the Maldives. The unpredictability of its descent sparked global outrage, with space agencies around the world criticizing China for neglecting standard re-entry protocols. Similar incidents occurred in 2020 and 2022 when rocket components from Long March missions fell into villages in the Guizhou and Shanxi provinces, causing damage to buildings and forcing emergency evacuations. Although no fatalities were reported, the incidents raised fears about what could happen if debris were to land in more densely populated areas. The root of these safety issues lies in the design philosophy of Chinese rockets. Many of China's space missions rely on inland launch sites, such as the Xichang and Taiyuan spaceports, rather than coastal locations. Inland launches increase the risk of spent rocket stages falling on inhabited areas, as boosters are discarded mid-flight and cannot always be guided to fall in unpopulated regions. While SpaceX and other companies employ systems to control and steer spent stages, such as Falcon 9's controlled landings on drone ships, China's Long March rockets are non-reusable, meaning the stages are simply discarded, often with little control over where they land. Another challenge is that China's space program prioritizes rapid development and national prestige, which sometimes leads to compromises in operational safety. The government is under pressure to meet ambitious launch schedules, leaving little room to address systemic safety flaws. Moreover, China's lack of transparency, compared to Western space programs, limits public accountability, making it difficult to assess the full extent of the risks involved. While Chinese officials occasionally announce debris zones before launches, the guidance provided is often vague, leaving residents and other nations uneasy about the potential dangers. These safety concerns have not only strained international relations, but also fueled tensions with countries like the United States, which are increasingly critical of China's space practices. As space becomes a more contested domain, incidents like these raise questions about the global responsibility of spacefaring nations and the need for more international agreements on space safety protocols. So, can China overtake SpaceX? It's not impossible, but the path is steep. With billions in funding and ambitious plans, Chinese companies are sprinting to close the gap. However, catching up with Elon Musk's well-oiled machine is no easy feat. Whether China can compete on a global scale depends on their ability to innovate, adapt, and overcome the challenges of reusable spaceflight. Thank you for watching. If you enjoyed this deep dive, make sure to like, share, and subscribe for more exciting content on the latest developments in space exploration. Stay tuned, and we'll see you next time. Take care, stay curious, and keep reaching for the stars.